Hello and welcome to my video today. My name is Corey Heisey and I'm a cyber-physical and mechatronics engineer. Today I'm just going to talk about, I've been working on using Flower Federated Learning. It's a Flower Labs platform. And mainly using Python for federated learning, which is a collaborative data secure method. So you can have different data sources all training one collaborative model in a secure way. So each source only sends up their weights of the model, not the actual data. And this can be useful for the hospitals, for example, or they're called like data silos. So like one hospital can collaborate with another hospital and not having to sacrifice their data. And there's other examples or use cases. Another one is edge computing or edge like IoT, Internet of Things. So each collection or data point collection can share its can improve on a model without sharing the data. And that's where we're kind of focusing on the federated learning in edge computing and having a cluster for collaborative computing, collaborative learning. And I've been doing a lot of testing with Flower on my little home test lab studio here, where I have Raspberry Pi, Arduino Uno Q as well, but I haven't been using it because I found it a little limited for it worked. I got it working, but it's a little limited for my testing. And an old Dell laptop running Omarchi Linux, and then my MacBook Air as the main server. And I've got it working a few different times. The first one, I just transferred the client Python script using copy SSH. So it was just copying the right in SSH. And then trying to deploy it using Kubernetes and trying to learn let's try to use Kubernetes. And I got that working. And then the one method that I've been using just to put the code that I'm testing onto the clients, on the client nodes are it's called Radical, which I made a video about already. And it's just Git. So it's just creating a repo, pushing to it. But the problem with GitHub, for example, is you have to log into it, and it's a lot more complicated than this Radical. And the Radical uses also SSH key, but setting it up is easier. So installing and creating a unique Radical node on each edge node was a lot easier, in my opinion, than having to log into GitHub or create a SSH access for it. And then Radical itself has a lot of data sovereignty for their Gossip. It's called Gossip peer-to-peer protocol, which I want to also dig into more. And every time I've been trying to experiment with, I've used different examples for the federated learning. And then I always think, I need to kind of keep it I should keep it consistent, because what's if I'm troubleshooting something, what's the actual problem or the problem point. And recently I tried to, so I was able to deploy with Kubernetes, and I built a package to deploy it through Kubernetes. And then recently I tried to deploy Flower using UDS. It's for it's called it makes SARF packages, ZARF, and it's called UDS Defense something, and it's and it basically has its own package that uses Kubernetes, deploys it to its nodes or target devices, and uses but has things like Keycloak in there for secure authentication, and Grafana Loki for monitoring, and Kubernetes. And of course, uses Kubernetes, not K3S, but K3D of some sort. And I was working with that, and then I found, maybe it's too large or whatever. And then, so today I built, what I'm calling a flower boilerplate. And I just used the flower getting started PyTorch video or example that they have on flower. And then using their superlink, supernode deploy stuff, but then deploying it on the distributed nodes that I have here in my home lab. So let's get into that. So I have my README file here, and it's nice because it has a setup node script that installs the packages and installs the virtual machine. Then you can just do the source to the virtual machine to activate it. And then we have the superlink node, and then we can do each. This is for testing it locally before onto your nodes or your deployment nodes. And then you run this to run the federated learning rounds that come with the example from Flower. So it's a PyTorch example. We have the server app Python. We have the client app Python script, and we have the task Python script. So we have the SSH console for the Raspberry Pi here, and we have the Omarchi Linux SSH console here. Here we have the supernode. They say it's deactivated. We can close it, and then each one needs to be in the virtual environment to know the command. We have this one, and then this is it calls this the scripts start superlink sh distributed. Okay, and then we go to the first. Then we have this one and supernode node 0 of 2, and then my IP server IP address of the server node here. Okay. And then here I can do flower run distributed stream. Okay, so round 1 of 5. So I changed it to 5 rounds just to kind of change it up a bit, because before it was round 1 round or 3 rounds, sorry. And also the supernode superlink shows it here. And they're all connected here. And the first time it also downloads the dataset. So this is like I said, the PyTorch getting started, quick start PyTorch example, but with the nodes, the edge nodes connected. And then now, so I can, when I want to experiment with different deployment methods or different protocol communications or just the model itself. Okay, let's try 100 rounds and see the results. Then I can have this one set up, because like I said, I got it working, this sort of method of just like put the code on there, and then it kind of, let's play around with it, and then it would kind of get I wouldn't know if I had troubleshooting problems. I wouldn't know which part was it, because I didn't have it working at first. So this will be a good place to get started. Every time I want to start tinkering, I can just create a new branch of the feature or goal I'm trying to do with this next part, run it, make sure it works again, and then do the changes that I'd like to do. And I think that will be a good step for continuing development, because part of the things like the UDS thought it was interesting because it has the Grafana, Prometheus, Loki infrastructure already in it to do the monitoring. And I had started implementing Grafana and to monitor the CPU and temperature, and I wanted to monitor also the federated training, the training rounds. And so having it all part of that would be a really nice implementation. But I did find the UDS was a bit big and bloated or bulky for it. But if that's what I want to test and the edge node is like big enough, then it should be okay. Or I can just like optimize it and clean up anything I might not need to use. So, but yeah, now I have a starter boilerplate, like I said, that I can just do it, just have it, just go for it, just give her. And yeah, so cool. Thanks for watching. Hope you enjoyed, and until next time, bye for now.